This video focuses on adding, subtracting, and multiplying radicals. So this first slide is just adding or subtracting radicals. The rule of thumb to add or subtract is you must have like radicals. That must mean you must have the same index and the same radicand. So here's an example C. We want to break down these radicals. So let's start with the square root of 18. You can break down 18 as 9 times 3. Then the next radical, you can break down 12 as 4 times 3. The last radical you can break down as 9 times 3, which is 27. Now, the square root of 9 is 3. So that's going to go out in front. And then you still have a 3 out in front. Your leftovers is this 3. Then plus 3, square root of 4 is 2, so that goes out in front. And then you're left with this 3. Last radical, you have a 2. The square root of 9 is 3, so that goes out in front. And then you're left with a square root of 3. Now we need to look in front of these radicals. Each of these radicals has a multiplier. So 3 times 3 is 9, and we have the radical square root of 3. Next one, 3 times 2 is 6. Radical is square root of 3. Last one, 2 times 3 is 6. Square root of 3. Now notice, all three of these radicals are considered alike. They all have the same index. Their index is square root. You don't see the 2 there. I'm just going to go ahead and put it there. That's fine. And then they have the same radicand, 3, 3, and 3. If that's the case, we can go ahead and combine their coefficients. So the coefficients are 9 plus 6 plus 6. So 9 plus 6 plus 6. And then what we say, the radical comes along for the ride, so square root of 3. Now we add those numbers together. 9 plus 3 is 15. 15 plus 6 is 21. So 21, and then square roots of 3. This next set of examples are multiplying radicals. They have the same rule. You must have the same index, but you don't need the same radicand to multiply. So let's take care of the first example. The square root of 5 times the square root of 10. They are both square roots. They both have an index of 2. So I multiply the radicands together, the 5 and the 10. So 5 times 10. You could go ahead and multiply that 5 and 10 back together to give you 50, or you can break down 10. 10 can be broken down to 5 times 2. 5 times 2. And then you still have this 5 in front. Now remember, this index is a 2. We're looking for pairs. The square root of 25 is 5. So the 5 goes out in front, and then I'm left with this square root of 2. Second example, we have like radicals again. They both are square roots. They both have an index of 2. In this case, they both have a radicand that's the same. They're both 6s. You don't have to have them be the same. So we multiply like parts. We multiply outside stuff to outside stuff. So 3 times 5. And then we multiply inside stuff together to inside stuff. So square root of 6 times square root of 6. Now the purple, 3 times 5 is 15. And then square root of 6 times 6, that's square root of 36, or 6. And then you would multiply 15 times 6. Last example, another radical times a radical. They both have an index of 2. So you multiply the radicands together. So we have 15 n squared times 10 n cubed. Now we're going to go ahead and see if we can break these pieces down. Well, we can rewrite 15 as 5 times 3. Then we have n squared. We can break down 5 times 2, which would have been 10, n squared and n to the 1. Now, since my index is a 2, I'm looking for pairs. So I'm going to regroup. This 5 and this 5 become 5 squared. Then I have a 3 and a 2 left. Then I have an n squared, an n squared, and an n. What comes out of the radical is anything that's raised to the second power. So the square root of 5 squared is 5. The square root of n squared is n. The square root of n squared is n. The things that are not going to come out are things that are not raised to at least the second power. So these pieces are going to stay underneath the 3 times 2 times n to the 1. Now let's just clean this up. We'll look at the front. 5 times n is 5n squared. And then we have the square root. And then 3 times 2 is 6.